Last episode, we swapped GPT-2 into a modern decoder, and I kept saying one swap matters more than the rest, grouped query attention, because the KV cache shrinks. Now I owe you that story in full. Because the KV cache is the single thing that decides whether you can afford to run a model, and there is a whole ladder of tricks to shrink it. First, what is the KV cache and why does it exist? The model writes one word at a time, and every new word has to look back at all the previous ones. Recomputing that every step would be agonizingly slow. So, the model keeps a notebook. For each word, it stores a key and a value and just appends. Fast. But that notebook lives in GPU memory, and it grows with the length of the conversation and the number of users. That is the whole problem. Rung 1 and 2 of the ladder. The old way, full multi-head, gives every query its own key and value. Biggest notebook, grouped query lets groups of queries share one key value pair. Llama 3 uses 8 shared key value heads at every size, so the notebook gets 4 to 8 times smaller and quality barely moves. Push it to the extreme, one shared key value head for everyone, and you get multi-query, smallest notebook, but now you can feel the quality drop. Rung 3 is a different idea. Stop looking at everything. With sliding window attention, each word only looks back a fixed number of words, say 4000. The trick is that attention stacks, so after a few layers a word's reach is still effectively global. And because the window is fixed, the notebook can be a fixed size ring that overwrites the oldest slot. It never grows. Mistral used a 4000 window, Gemma went further. 5 local layers for every one global layer, with a window of just 1000. Rung 4 is the cleverest. Instead of sharing the notebook entries, DeepSeek compresses them. It squeezes each word's key and value down into one small summary vector, stores only that, and reconstructs the full key and value when it needs them. The summary is dramatically smaller, about 10 times less memory, which is exactly why DeepSeek can serve a 100,000 word context without melting the GPU. Here is the ladder, 4 columns, same model size, so the only thing that changes is the attention trick. Watch the little notebook size per word meter under each one. Multi-head, the baseline. 32 query heads, 32 key value heads. The meter is full. This is the notebook everything else is trying to shrink. Grouped query, same 32 query heads, but only 8 key value heads, drawn as 4 query heads feeding into each shared key value box. The meter drops to a quarter. This is the rung almost every modern model stands on. Two extremes side by side. Multi-query, one key value head for all 32 queries, meter almost empty, but a small red quality risk tag. And sliding window, a fixed size ring of slots, the oldest overwritten, meter capped flat no matter how long the text gets. And the top rung, latent attention, the full keys and values go through a down projection into one tiny latent vector. That is all we cache. Then an up projection rebuilds them at compute time with a small separate rotation path on the side for position. The meter is the smallest on the ladder, about a tenth of the baseline. This is how you serve a giant model at long context affordably. But notice, this whole episode shrank attention's memory. Next, we attack the other big block, the little neural net. What if, instead of 1, the model had 256 and only opened a few per word? Thanks for watching. Like and subscribe for more videos like this, and I'll see you in the next one.